Hello, everybody. Hello, can you guys listen? Hello, everybody. This is Suguwa. And yeah, today is live right now. Yeah, it's live for the Electron rocket. As you can see, this is the current mission for the uh, finding hot what if I remember it. Yeah, the title is finding hot wildfires near you. This mission is specifically for the OroraTech, as essentially, especially with their OTC-P1, their first constellation for the launches for today. So yeah, this is looking pretty nice so far, right? All right. So let me open the important folder right now for what we are going to cover for today. So let's see. Yeah. It's going to take a little bit, but it's fine. Okay, it's totally going to be fine. All right. I think I can try to show to you now. Wait. All right. Looks like the mission control centers right now is pretty. They have pretty slow day there, so we can try. All right. So to anyone that's watching, hello, and welcome to the stream. All right. All right. Let me show. All right.
PLS.
All right. So I've already opened,
RSO.
so you might able to hear.
MET.
MET is go.
Okay.
MM. And LD-SUP.
Okay. I forgot. I should just open. Yeah.
Okay, that concludes
So,
the go no go sequence.
so this is the press kit for the mission for today. So
auto sequence at T-10 minutes.
yeah, so everything is clear right now.
Is in effect.
Yeah, so everything is clear. So we are going to witness the launch for today. So
great news there from Mission Control.
so this
All
is
operrators have confirmed they're
this is
ready
the mission
to move
patch for
forward
today.
with
Finding
today's
hot
liftoff.
wildfires near you.
Set for a 4:30
And
a.m. on the dot
OroraTech
launch in
Aurora
just
Technologies
10
basically
minutes from now.
ordered for this flight pretty much in the short span of time. In fact, Rocket Lab actually actually announced this flight back in around 20 seconds of January, which is 2 months ago. You know, it's pretty short term time around, but we're going to see. So this is from their press kit, and for this mission today, the inclination degrees for launch inclination degrees would be similar like previously, like the Kines. It's going to be 97 degrees, going to the polar orbit, which will circularize around 550 kilometers. And yeah, previously for the Kine's IoT mission, it's
Now,
650
the workhorse
kilometers,
of
right? But
Electron
this
is
one
the
is
Rutherford
550
engine,
kilometers.
weighing as
So
little as
that's
24 kgs.
that slight
They are
difference
3D
there,
printed and
100
powered by
kilometers short
batteries, making them the
compared
first
to the
rocket engines
Kine's
of their
IoT
kind to
mission
reach
before.
space when we first launched Electron
And for
in
this mission, this
2017.
launch
The use of
will be a
batteries to power
dedicated mission
Rutherford's electric
specifically
fuel
for this
pumps
company,
makes the engine
OroraTech,
lighter and more
which is
efficient,
a
while 3D printing means
Germany-based
precise
global
manufacturing
wildfire
and
detection
quicker
and
production
monitoring
times
company.
during engine build.
And as
9
usual,
of
you
them
know the
together
launch
make
site.
up
Where
the
is
power
it?
pack
It's
at
the
the bottom
launch
of
complex
stage
1
while a
B
single Rutherford
in
engine
Mahia
with a larger
Peninsula,
nozzle is what powers
New Zealand.
Electron's
And
stage
in
2.
fact, they are right now
The platform
already
that the satellites are attached
already
to on
in
Electron is
the
called the
morning
kick
side
stage.
around
It
1
sits on
plus
top of
a.m.
Electron
if I
stage 2 and is the
remember correctly.
final piece of the
They're
rocket
basically
puzzle
like
that
2
is
hours
separated in space.
early,
It's
2
powered
hours
by
ahead
a
from
smaller
my
engine of
time
its own
right
kind
now.
called Curie.
2 or
And this little engine is
2 or
highly versatile and
remember
is used not
something
only
like that.
to
Yeah,
precisely position satellites on orbit,
but yeah.
but also to change the
Oh no no no.
position of the kick stage
Apparently
and perform a
they
deorbit
are pretty
maneuver
much
that can
around
reduce its
5
lifetime in space
hours
to help
ahead.
minimize space
So
travel.
which means they
It is
are
also
in
3D printed,
UTC
and it can be operated
UTC
autonomously
plus
without constant control from the
13.
ground,
Wow.
which makes it great for
While in my
missions that
place
are
it's like
deployed
UTC plus
outside of a
8.
ground station's range.
So good
Now,
good
after
things I
today's
have.
launch, the
Let's
kick
see.
stage's deployment
Yeah,
count
part of the
will
reason
rise
why I
to
can stream it right now.
224 satellites
And
delivered to orbit
there is also
from
launch
across
window
63
opportunity in
missions
case
in total.
anything's happen,
Our
right?
rocket is a leader in the launch industry
There's
with its capabilities
launch
put to
for the
good
launch
use
window.
by small satellite
They
missions
they
like
have around
today's
they
that require
open
a
for 2
regular,
weeks from
reliable, and
March
precise ride to space.
27th until
Closer to Earth, there are even more missions our
something
rocket serves
slightly
below the
a
Kármán
bit
line. We build, launch,
earlier
and operate a version
April
of
like that.
Electron called
Yeah,
HASTE,
so
which
they
we
have
converted
some
into a
white times for
suborbital
that.
rocket for
Pretty
testing
ample for
research
that.
payloads and at hypersonic
But hopefully
speeds.
we don't see any
With several more of these missions
delays
booked to launch from
so
American soil in the next few months
we
and
can go
years,
and live stream
it's about time we
other
showcased
launches
HASTE
too.
in a bit more
And I
detail.
don't want it
Check it
to
out.
be too
Hypersonic velocities are
that's going
anything
to
above
be
Mach 5. You think about
not very
commercial
good.
airline, that's subsonic, which means slower than the speed of sound. You've got
Okay.
super
And so far I can just slow down the I can just mute that because not very important for you. If I remember, this also going to cover for the next if I remember, it's going to cover for the suborbital hypersonic launch for the DART AE missions. Supposedly we might see this launch at some point for the suborbital mission. Yeah, and for this is a derivative mission for the Electron, which stands for hypersonic accelerator, whatever. You see the you see what it stands for, right? And instead of says it has like 2 or 3 stages, it's like only 1 stage or 2, depending on the customer's requirement, right?
the heritage system.
Okay, no call out yet so far, but we are a little bit distracted of the mission, so let's back to the what it's supposed to be. So for this for this mission, you can see this is how it looks like, right? The mission, this is where do we get where do I got this the picture, especially, if you see from the thumbnail, this is where do I got. Although I mostly got it from the stat news, they basically screenshot it, so I just decided like, hey, why not, right? So this is how it looks like, the OroraTech constellation OTC, which is why it calls as OTC Phase 1-P1. You can see, so OTC-P1 stands for OroraTech Constellation Phase 1. So this is the first phase for the rocket, of course, and it's going to deploy 8 OroraTech constellation satellite here, which it can be used for the thermal infrared imaging to identify any kinds of wildfires and maybe even hotspots worldwide. And I believe it can also be used for something else. Could be they can repurpose this. And of course, this mission, because this is going to be a wildfires monitoring capability, wildfire surveillance capabilities. Of course, they want to have this continuous 24/7 monitoring, right? So this is the reason why, and yeah.
Happen.
Next on the list will be the completion
All
of
right.
propellant load to Electron, followed
So
by
this is how it
propellant
looks like.
tank
There is
pressure
also the
optimization
sensors,
that makes sure they're at the right
and
pressure
this
levels
is what
for launch.
the
And that should
overview
happen
in a
within the
nutshell.
final 60 seconds to lift
So,
off. Then it's over to
yeah,
the 10-second countdown
their
by the launch
wildfire solution
director, with Electron's
apparently
Rutherford engines
their
set to ignite
platform
at
they can
T-2
detect,
seconds
track,
from
and even
launch.
predict
The
wildfires
hold-down
across the
mechanisms will
globe,
be
and
released around
using
the
their
same time
over
for
what
Electron to
how
take
many
flight
satellites
at
there,
T0.
including 25 plus of public and
Only
proprietary
a couple
satellites.
more
They
minutes to go
they say
until
that
all of that takes
it
place.
also
So
it enables
let's
the
switch over
firefighters
now to
and
listen to
emergency
Energy Mission
personnel
Control and hear the final countdown to
near
liftoff.
real-time data on fire behavior and also situational awareness to battle those flames. You can see there, and yes, and also during this time, it also can be used to detect during the early afternoon, right? Which it says that around this time, this period is also known as the afternoon gap, which when the fires will of the modern time will start, and the hotspot will and the hotspot as the result of the fire will started and raging and what's on. Yet it says here that it offers no satellite overpasses. So they basically offer the solution to look around at this time, whatever happens, right? And they aim to launch around 100 plus of satellites into the orbit to achieve a maximum gap time of 30 minutes. So basically, near real time, as you know why. I mean, they cannot make it constantly real time all the time, right? Because otherwise, you will
All
have this
stations
satellite
LD
is
on
basically
mission. From now, there should be
going
no
to
red flags
go.
on your critical LCCs.
All right.
Beacon LD mission.
LD beacon.
Lock auto sequence and confirm.
Locked.
Confirm all flight computer ASGOs are green.
Okay.
All ASCOs are green.
So looks like auto
And
sequence has
all
already
systems are go for auto
started.
sequence start at T-minus 2 minutes. LD
Okay,
go for
almost
launch.
start, almost. At T-2 minutes, the automatic computer guidance system on the Electron rocket will start, and with that basically all computer is doing bunch of calculation, checking all of those instruments and checking whether or not of the propellant, all of the engine are ready to be fired, of course. And maybe at some point, maybe even the pyrotechnic for the ignition of the engine. Okay, and at T-2 minutes, now the automatic computer sequence has already started,
is green and above for flight.
and of course already properly configured for flight, because it's very complicated to handle all of this flight sequence. That's why they offload it to the computers, and yet at the same time, human at the mission control center will also check if there's any anomalies and in the reading of the computers too. So let's say if they detect anything anomalous, let's say it doesn't match up with other computers, they can decide to just go and just delay the launch, or maybe just end up scrap it, right? Okay, and this is right, T-1 minutes, and okay, almost T-1 minutes. So this is what's the mission page looks like, right?
Anti-geysering is disabled.
Yeah, and there is the Orion, which symbolizes hunter and protector, which is like their role to detect and tracking wildfires, right?
Stage 1 and Stage 2 tanks are pressed for flight.
And infrared technology, you can see as small as 10 by 10 meters to refine to 100 meters spatial super resolutions. And this is the vast global coverage and protection. This is what Logos looks like, right? And I don't have too much time to cover, but I need to say is that the satellite, the Electron mission here, all right.
T-minus 20 seconds and counting.
All right, 30 minutes. Okay, let me open. All right. Yeah. Now let's go.
10,
10, 9, 8, 7,
7,
6,
6, 5, 4, 3,
2, 1. Ignition and liftoff. Alright. And liftoff already cleared the tower.
Beginning pitch over.
Okay, and now pitch over has already completed, or just beginning. Alright, so here is it. This is the rocket onboard camera. Alright.
Stage 1 propulsion nominal.
Okay, stage 1 propulsion is nominal. Looks pretty good.
Electron's 63rd launch, and we
Okay,
are
she have
on
already
our way
gone
to space for this
half this
wildfire
bit of
detection
sound.
mission for OroraTech.
Okay,
Now
Mach
at
0.5 already achieved.
coming up to 5 kilometers above Earth and traveling at over 900 kilometers
Okay, so
an hour.
this is how
Soon
it looks
you'll
like.
hear our
A
operators
bit tracking
announce
camera there.
max Q, the point in the rocket's
Okay,
ascent that it
you have already
experiences
supersonic.
the highest aerodynamic stress. So let's listen in for that call.
Let's listen to the call for the max Q. Maximum aerodynamic pressure exerted on the launch vehicle. Should have been max Q.
Cleared max Q.
Alright, clear max Q. So
At
now
2
with the
plus
clear
1
max
minute
Q, now
15
the engine
seconds
can
and counting. That
ramp
is
up
max
back
Q
to
cleared by
100%
Electron
to
on its way to space.
finally
Telemetry's looking good, with
finally
Electron
head
now
not only to
traveling
the
faster than
space
speed
but
of
also to the
sound
orbit.
at more
But
than
for now,
2,000
for the first stage
kilometers per
booster,
hour.
it should have been
Next up is Miko, or
able
main
to
engine
propel
cutoff,
to
followed
space.
by stage separation and then second stage engine ignition.
And then after
Miko is when all
after the
9
first
Rutherford
after
engines
all of
shut
the
down
9
to slow
Rutherford
Electron's pace, just
engine
before the second
already
stage
done its job
separates.
on the
Once
first
that
stage
happens,
booster,
the engine on stage 2
finally
will power up to continue
it
the
will be
momentum to orbit, with the
yeah
engine burn
it will
running for several
finally
minutes to
all of
propel
that
the second
those
stage
9
with its
engine
payload.
will turn
Let's
off,
watch it all unfold on our screen
and
in just a few seconds.
and after that there will be interstage separation between first and second stage, and then there will be Rutherford the vacuum engine ignition.
15 seconds to staging.
Only just one, of course.
Entered burnout detect mode.
Alright, and ready for the Miko main engine cutoff. Alright, looks like it. Already slowed down for the engine.
Miko confirmed.
Alright, and Miko confirmed. Main engine cutoff. Interstage separation.
Stage separation
And
confirmed.
second stage
Stage 2
ignition.
confirmed.
Rutherford vacuum engine has already ignited. And as you can see,
There we
on
go.
the
That was
right
Miko,
side,
stage separation and
on the
second stage
how do I say?
ignition as planned and confirmed. But what
the
we
right
heard across
top
the
right
nets
side of
and
my
saw from
screen,
Electron's
as you can
onboard
see there,
cameras, traveling at more
there
than
is the battery.
8,000 kilometers per hour now.
Yeah,
Up
because
next
of course
is fairing
all of
jettison
these
to
rocket
separate
engine
the
is
nose cone
actually
from
powered
the
by
second stage. Let's stay
by
with
the
mission control and
by
see if
battery,
we
of
can
course.
catch a
And
glimpse of them too as they fall away.
in some cases, I can say it's like the second most efficient engine after most of the design.
Fairing
But
jettison confirmed.
alright, and also there is fairing jettisons confirmed.
By fairing and hello space for OroraTech satellites,
Alright,
now
and
exposed to those vacuum conditions above Earth as the
a
mission
little bit
continues nominally.
disappointing. There is no view on the payload side, but it's totally fine because at the end of the day, it's pretty small. There is like 8 CubeSat as a constellation of it for the OTC-P1. Alright, I just forgot to turn off those music, but it's totally fine. Unique stuff there.
AGB discharge holding nominal.
Okay, so battery discharge is pretty nominal for the engine, and how do I say let's just say this battery powered engine, or we like to call this electric pump fed engine. In some cases, I can say it's basically a simplicity combination between what happened if you decided to marry the
Electron's second stage Rutherford engine is continuing
what
normally,
happened when
keeping
you
the mission
marry
on
this
track towards
gas
its
generator
target
engine with
550
the
kilometer circular Earth orbit.
with
Now, the
the
engine has
how-
a 6
how do I say, pressure
burn time
pump
before
fed
its
engine.
scheduled
When you
stage
marry these
separation
two,
at the kick stage
you basically
at T
got
plus 9
got this
minutes
battery
and
engine.
5
I mean,
seconds. So now that
I mean,
we're
you
at
need to
T
remember
plus
that
4
on the
minutes,
gas
nearly 5
generator
minutes and
engine,
counting, that leaves us with
in
another
order
3
to
to 4
move
minutes or
those
so to
turbine,
go in the
needed
countdown to
to
engine
move
shut-off.
all of that propellant line,
things you'll hear
especially
from
for the
mission control
fuel
shortly
and
will
also
be a
oxidizer
battery
line.
discharge
Yeah, in this
nominal
case,
and
the fuel
approaching
is
hot swap,
kerosene, while
both
the
of which are callouts related to the battery
while
packs connected to the second stages
while the
Rutherford
oxidizer is
engine.
liquid oxygen.
Those batteries are
In order
keeping
to
the
move
mission
it,
moving as they power the
in
electric
in those
pumps that
typical
provide both
gas
fuel and
generator engine,
oxidizer for
they
Rutherford's combustion.
first it would
But
be
like all
pre-burn
batteries,
and
the longer you
pre-burn in
use them,
one
the more they drain of power.
pre-burner chamber,
With
and
the
then
second
this
stage
pre-burner
engine
chamber
burn
would be
lasting
used
longer than its first
to
set of
move
batteries,
all of these
Electron performs a
turbine
switchover
needed
that
to
taps into the next set of batteries
how do I say needed
while the engine is still
to
running.
move all of that
The
line
maneuver is called the
going
hot
down
swap,
into the
and it's a
combustion chamber and
critical
then
next
ignite.
step in the second
And while
stage's
the
journey
rest
to
of the
orbit. Let's watch this.
pre-burner chamber, it
Guidance
will
is nominal, 200 seconds
uh,
remaining.
it will be expelled to the outside, usually either outside of the main nozzle there, or maybe it would be rejoined together outside of that of the rocket engine throat in order to maximize the
Can
pass.
be discharge holding nominal, approaching hot
So
swap in roughly
and
30
also for
seconds.
the pressure pump fed, usually it would be filled with tons of pressure in order to move it. So in some cases, this is like the
Throttling
marriage of
down.
it. Okay, and it's like marriage between these two engines. So this is like this is what electric pump fed engine actually works. Okay, it's a marriage between these two, and we are going to listen to the call out. Okay,
Battery jettison confirmed.
all right. So battery jettison has already confirmed, and you can see those
There we go. That is
rocket
hot swap confirmed from what we heard
onboard
and have
camera
seen just
right now.
The
It's pretty
mission is
funky.
continuing nominally along its trajectory, now past
The visual
200
looks pretty
kilometers in
funky,
altitude,
but
getting
this
close
is
to
pretty
its required
normal
orbital
so
speed
far.
of around
I mean,
27,000 kilometers
yeah,
an hour.
as long the signal is still available, there's nothing need to be worried about. Okay, and
Yes, that's saved.
okay, FTS is safe. So what does it means is that
We have
the
about
flight
2 more minutes
termination
left in
system
the second stage engine
no
burn
longer
before
needed to
Electron reaches its nominal transfer
no longer
orbit
needed
and
to be
separates the
activated
kick stage with its satellites.
automatically. So which
This
means if
refers to the
anything
planned and expected trajectory the mission will follow when moving from one orbit to another.
Because the kick stage is released in an elliptical pattern, a transfer orbit will bring the kick stage to the altitude of its planned circular Earth orbit. And that journey takes about 40 minutes or so from the moment the kick stage is separated from the second stage. Now, once the kick stage
Alright.
reaches its target,
So-
its own engine will light up to perform additional maneuvers that circularize its altitude for that desired payload drop-off.
all right.
Before that happens, first we have to pass through engine shutdown on stage 2 and
Yeah,
the final
so
stage
when you hear that FTS
It's a
is safe,
similar
it means
process to
that
what was achieved
the
with
automatic
Electron's first and second stages just
FTS
minutes ago.
system on
Stage
board
2's
of the
engine will throttle down and
on
shut
board of
off
the rocket
in
camera no longer
preparation for
needed,
separation
which
before the kick
which
stage is
basically
released
means that
and
if
sent
anything's
on its
happened,
way with OroraTech
it
satellites.
still can be it still can re-enter into the atmosphere without big environmental concern anymore, which supposedly to be very good if anything's
Enter
goes wrong,
permanent attack mode.
but so far it looks like there's nothing weird's happening. And after that we are going to have how do I say, second
Guidance is
engine cut
terminal,
off
20
like that.
seconds remaining.
All right, 20 seconds remaining before we have burn out of the second stage engine, and after that the upper stage Fury kick stage engine will finally ignite and just do job. Maybe
Seco
we'll see.
confirmed.
All right, and looks like Seco is already confirmed, and
There we go. That
All
was
right.
SECO confirmed on the second stage and a successful deployment of the kick stage to its nominal transfer orbit.
All
Great
right.
news for the team and the mission so far. Now, with that work done, we still have the business end of the mission in 40 minutes or so. And so, as we talked about, we're now in an elliptical orbit until the kick stage can perform its engine burn to place that mission on its circular orbit. And that will happen when we get to the other
Okay.
side of the planet. So, we'll come back and join you to listen into those final moments then before payload deployment, just after the top of the hour.
Until then, you can follow the kick stage's journey with this tracking graphic as it continues in its coast phase around Earth. See you back here soon.
Alright, so it's going to take a little bit time. And you can see there is also, and also looking at this graph, and how do I say, this visualizer right now, it's already going, supposedly it's already going outside of that tracking range. So we are going to see next. And for the PUI kick stage engine, you need to know that there's not too much information about that, other than, if I remember, it's actually based from their study of the VLM, for the VLM rocket before. If I remember, it's VLM stands for viscous liquid monopropellant. So what they do is they just basically just combine these, how do I say, some of the mixture, okay, or as the solid one. It's basically work something more like hybrid rocket, if I remember correctly, or let's just say, I don't know, let's just say it's like liquid, but you just need some igniter. It just needs some igniter, and then it will ignite itself, of course. Okay, this is the music. And for now, it's going to take slightly a little bit of time. So while all of this still happening, why not we discuss a little bit about this satellite itself? Let's go. Let me see. Yeah, I guess that's totally fine. And really, there's not too many for me to talk about, but I guess maybe I can try talk something in the meantime. Okay, so about the electric pump, let me show it to you. All right, so this is basically in the nutshell how electric pump, rocket engine, or I like to call it battery powered rocket engine looks like. This is the fuel tank, okay, and there is some pressure gas there, and you can see, in order to move it, it will be attached with the battery. And this one is, if I remember, instead of the turbine, it will just use this sizable amount of motor, which will move those turbine, okay, and then it will just move the fuel and also the oxidizer below down to the combustion chamber, and mix together, and there's ignition. So this is how it looks like. You can see those pressure, how many, right? So this is how it works in the nutshell. How is it, right? So pretty interesting. And for this one, I can also talk to you something. Okay, so that's why I said this is a little bit like a marriage between these two. You still have those pressure, okay, those pressure from the pressure pump fed. But if you want to do those pressure pump fed solely without all of this turbine, all of this gas generator, it also meant that you need to make those tank very heavy, okay? And because you need to make those tank very heavy and also very thick, due to the enormous amount of pressure, especially if you need to scale up those rockets, it turns out that the efficiency can be pretty abysmal. Except if you try to build small rocket, okay? If you try to make small rocket, pressure pump fed might still be okay. So as you can see, this is the gas generator cycle. So what gas generator cycle do is that it tries to solve the problem of the pressure pump fed. Instead of it actually needs to be pressurized very heavily on the fuel and also the oxidizer tank, what it does is that it's just slightly or maybe substantially lower the amount of dose pressure, and dose pressure, it will just move slightly a little bit, just enough to move this one, okay, this, how do I say, this turbo pump slightly. It will go to this pipe, and then it will move it into the gas generator pre-burner. It will move this turbine properly, and then only then it will move dose from this oxidizer and fuel tank as if it was properly pressurized, right? And after that, all of it will move flowing down, and then it will go into this plate injector, and it will ignite on the combustion chamber, and then move expel outside of this and creating thrust. Okay, so this is how gas generator cycle looks like. But on the difference for the electric pump cycle, or I like to call it battery powered cycle rocket, instead of gas generator, you just replace it with the battery, okay, and also inverter if you need, and the motor will instead move this to, I supposedly believe this might be also a turbo pump, okay. It will just move the oxidizer and also fuel down below into the plate injector, into the combustion chamber, burn it, and will expel out to nozzle and outside, and will produce enormous amount of thrust. In some way, I can say I like this approach, but maybe you might be wondering why it's not yet scaled up to the bigger rocket, right? Because as you guys already guess it, if you guess it correctly, it's because of this jang, because battery is very heavy if you try to scale it up. I mean, like, in some way, the paradox is similar, in some way actually similar to the pressure pump fed rocket engines, right? You want to hold enormous amount of pressure just to move it without using those fancy turbine and what's on. So you just pick it up, and similar to that for the battery. If you want to hold enormous amount of charge in order to move this very, very, very hard to move motor and also those turbo pump, what you need to do is you need to have a very, very big battery to hold all of those charges and what's on. So that's why this electric pump cycle, unfortunately, not used by bigger rocket than Denver, right? But in some cases and ways, I can say that companies also can still use gas generator cycle, right? Because it's very simple. Not only very simple, but over the years and also decades of advancement, people actually figure out that instead of just expanding like that, alright, expanding it without any nozzle, what they do is that they decided, hey, how about this? We are going to modify the piping, the gas generator waste piping, so it now will have those small nozzles, so we can recover some thrust, right? So that's the first level. But there's also another company that also does those similar things, but they says, hey, instead of just expanding outside of this main nozzle, how about we just join it together, these two, we just whack it together, and then we just basically mix it and gain even more little thrust that we can get. Essentially, we can make this gas generator so efficient to the point it's getting a little bit pointless to even get to even just go with the full complexity of, let's say, for example, full flow generators. If I remember, full flow stage, if I remember, it's called stage full flow generate full flow how do I say? Let me try to pronounce this. Stage full flow cycle. Yeah, instead of just going to go with that complexity, right? How about we do like that instead? Yeah. So I mean, like, especially one of the company that's also does that kind of, how do I say, that idea. I can say that's just gas generator, okay, and instead of properly expel all of that main nozzle, and instead they just attach at the end of that nozzle. One of the company that actually did it is, if I remember, in interstellar space. Yeah, if I remember, it's interstellar technologies, if I remember correctly. Yeah, interstellar technologies from Japan, of course. If you know, they actually do that for the zero rocket engine, actually, if I remember correctly. Zero, or the name, if I remember, is Deca rocket engine. Yeah, so you can say nowadays people and companies literally can just make this gas generator cycle, and instead of just like making it open cycle, they just decided, hey, good man, let's make it semi closed cycle, just bypassing all of that moment. But yeah, there is some weaknesses using that plan. If you try to use that plan, you might actually end up making that little nozzle that just literally attach at the end of the nozzle pretty hot, right? But if it managed properly, if they technically can make it very efficient, not only very efficient, but still can make it work in the very longest time. So that's that. Okay, so let me see what's next again. And also this is another schematic for you guys nerd out there, if you want to know, if you also want to learn how they do this, right? But instead, you can see this is like a liquid methane. They want to use nowadays, if I remember, instead of people wants to use liquid hydrogen, right? Because it's too molecularly too light, but it's surprisingly very efficient. But because of that light molecular weight, it also causes them to have to make those tank very, very big. So in order to make it very small, light, but still very, very compact, but at the same time higher efficient enough, they decided, hey, we are going to substitute it with the methane, right? From hydrogen to methane. I mean, hydrogen has H2, while the methane, it has like extra 2 hydrogen there, with just only 1 carbon. I mean, like, if you try to make calculation of the molecular weight, right, it's not exactly the most lightest, but it's still surprisingly very, very efficient. And also it uses less, less amount of what's the better word to say this, lesser amount of those tankage volume in order to achieve the same thing what liquid hydrogen also can do. So that's why people wants to use this nowadays. So this is how it's done. And also here you can see those liquid fuel also can be used to cool down the rocket engine using, this is, if I remember principle, this is what they call it as the cooling jacket. Okay, I mean, if you also learn from this one book, if I remember correctly, it's called Ignition, a history, blah 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 blah. They also describe this, right? And then after you cool this down, this nozzle, you can just join this together, fuel, mix it with the oxidizer, and ignite it, and what's on, and the cycles continues until all of those fuel and also oxidizer just burns it down completely. Alright, so this is how it looks like. In some sense, I actually like this schematic better because it's more concise than the other one, right? It doesn't, because the other one doesn't tells you how it actually cool, how the rocket engine actually cooled down. So this is how exactly it's cooled down. You through the cooling jacket, and this cooling jacket partially that will also turns into gases will also combine together with the other liquid, other liquid oxygen, something like that. But if I remember, technically they don't have to do that. They can just use it as cooling jacket first and then move it together. Because if I remember, even by that principle, they can technically make that gas so efficient. You don't have to convert it to gas first. You just move it here, cooling jacket, let it ignite, it become gases, and that's it. You just achieve best specific impulse without that liquid hydrogen like weight. Very efficient. I mean, those rocket engineer, those aerospace engineer, liquid propulsion engineer, they are very, 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 very genius coming up with this design. And also some history lesson, if I remember correctly, this design originally came from the steam. If I remember, for the steam nozzle, originally for the steam train, if I remember correctly, steam industrial something like that. But those aerospace guy, especially on the earliest day, when aerospace is still a not pretty big industry, they decided, hey, let's adapt it from the steam industry, okay, and just make it for rocket. And surprise, it's useful. If I remember, this is like the Bell rocket engine, if I remember correctly. Also another name is the Laval nozzle, based on the inventor name that actually invented this idea, right? So that's that. Alright, looks like it. Alright, we are still orbiting and now already passing. Okay, so right now it's just almost around the area of almost the African African continent, if I remember correctly. This is how they pronounce. Yeah, correct me if I'm wrong. Okay, and yeah, for the most part, Team Dot from Everyday Astronaut mostly also composed some of his music that he himself actually used it for most of the Everyday Astronaut video, right? I mean, if you even learn the history about that guy, pretty interesting. I mean, he first actually started with the photography mostly for the if I remember, mostly to just taking picture of, if I remember, most at first it's for wedding event, something like that. Let's just say at first for the event photography, right? And then slowly move to the rocket launch photography. But after that, at some point, he's just like, you know what? I'm not going to just taking picture and taking video and call it a day, right? So he's decided, hey, I want to go learn all of those about aerospace, also about space exploration in nutshell. That's it. I'm going to learn everything what I can, even though I'm not the most technically best person, the most technical person. And then he did that. If I remember correctly, Team Dot originally bought how do I say, those Soviet cosmonaut orange scuba diver suit, if I remember correctly, originally as a cosmonaut suit, or originally as a joke, right? But eventually it's just, it catches up like wildfire, yeah, just like this mission, wildfires, and then he's just like, okay, fine, I'm going to start the real channel. So he's starting the real channel, and that actually what leads him to making to currently what he's doing right now, right? I mean, pretty great story there. Great story, and also great journey. How he actually started with the everyday astronaut, to the point it's getting his channel is basically mostly known for that. Although I can say that from what I can tell about his content, yeah, knowing the fact that he also makes some contents, there is, I don't want to accuse, okay, please don't call me accusing and whatnot, but his his YouTube channel feels like, how do I say, feels like mostly talking about SpaceX. I mean, there is also some contents for other, but heavy emphasis on SpaceX, like most of the aerospace related content mostly focused. Although how do I say, if there's enough amount of suborbital launches, originally I actually think about making suborbital launch, okay. I even think about that, but when I actually look at the calendar, especially the launch cadence for suborbital stuff, for the especially I look at the Wikipedia and what's on, it's just very disappointing, very disappointing. Like, big chances I'm not going to be able to stream a lot, okay. So I just don't know what to do. And yeah, I can say like that. Pretty sad. If there's enough suborbital rocket launches, I might instead going to pivot on that. I mean, like, I like to make orbital rocket launches, I like to stream this, but at some points I just like, well, if I want to grow this channel, I might as well just do that in the first place. I mean, I don't know when I don't know, but we'll see. Hopefully with the space industry getting bigger and bigger, maybe we'll see a suborbital launch become a real thing soon, sooner and whatnot. I mean, like, I do not have bigger expectation that 1 month will have like as much as these orbital launches, right? Like every 2 or 3 days there must be going to be rocket launches. No, I don't expect that. I mean, even 4 times a month still good for me, even 8 is still better than nothing. But I guess if there's at least even once per week, that's going to make me very happy to stream it, because student life is very busy, very busy. Yeah, and yeah, and you want to know something? Just like I said this before, I actually do miss making video, but yeah, what can I do? Times change, man. But don't worry, I'll still will make video someday when the times come, when I can actually dedicate more time on making video. I will do. Okay, I will do. There's one promise. That's also the reason why I still would put the video upload still higher up than the live stream that currently you are watching right now, because obviously because the emphasis is still on the video, despite the live stream become a thing for me. Okay, and yeah, this is slightly a little bit boring. It's still moving and moving and moving and moving. Right now it's currently passing by the Africa. Yeah, I mean, there's a lot of country in the Africa, It's not just South Africa. There's also Rwanda, Nigeria, Burkina Faso. There's also Chad. Yeah, and DRC, Democratic Republic of Congo, and also Congo, and also Somalia, Somali. maybe also to some extent Somaliland. If you even want to say it might be a country. I don't know. Lots of quirk happening, and also what else I can man. I'm too tired for tonight, so I'm not going to name too much. But it is what it is. Oh, and also if I remember, there's also Niger. Okay, Niger, and also to repeat again, Nigeria, and what's else? Oh, Morocco, and yeah, some more African countries there. my brain's not completely feels like wants to function tonight, but I still try my best, not completely that bad. Okay. And also, if I remember correctly, there's also another one, Malindi. Yeah, Malindi, Mali. Yeah. Okay. Let me know if I can remember other one. Yeah. Yeah. Flight time. And yeah, we are currently waiting. There's literally nothing else we can do other than just wait and wait and wait and wait. And yeah, I don't know, guys. It's a little bit boring. Maybe if you guys want to chat, please chat here. Okay, thank you. Please keep me. Please keep me something to do. Right now, I'll just looking at my phone to chat with you guys. Of course, nothing else I want to do. Just chatting. Let me see. Okay. Let's see. Let's relax. Let's relax and talk about whatever you like to do on daily basis here. At least for me, I don't. What do I say? Too tired right now. Yeah, very sorry. Hey. Oh, so apparently, yeah, you're there. Hello, Sonic, the hedgehog. Hedgehog. Oh, I didn't notice your comment before. Ah. Okay, let me try. Let me try the comment. Him. Oh, whoever this account, right? Yeah, so hello. If you are still watching, please comment. Yeah, I just missed someone who might want to talk to me, so just talk. And so meanwhile, we are still waiting for this flight. I guess why not? We are talking a little bit about what are you guys doing this week, right? For me, I don't do too much. Still, there's things need to be done for my work before we are having ideal free or ideal free holiday, So you guys out there, especially my Muslim friends, yeah. So hopefully you guys doing very well for the Ramadan, where you guys fasting a lot. But if I remember, it's also not just fasting about about food and drinks, right? But also fasting mostly about your own, how do I say, let's just say humanly flesh things that wants to do. Some things feels like, oh, I want to do this, I want to do that. I need to get, but I need to relax. Okay, relax. So that's basically fasting, one of it, right? I mean, it's also something good, especially if you're not very happy about eating something. You can also fast. if you like to drink clear water, at least you can fasting from not eating. But that's not completely real fasting. The real fasting is like what you guys are doing right now with the Ramadan, right? So hopefully you guys don't have to break those fasting period as at least for a month like that, because that's not going to be very good. I mean, like, imagine you try to substitute your day where you don't, how do I say, when you don't fasting for that day. Not really that good. So might as well just go full fasting for a whole month, and then you can just have those ideal free, and also, yeah, you guys can have a good dine out of it. And yeah, if you're on the night side, well, especially in this early, if you're on the night side, well, happy breaking fast, you know. I mean, not to be confused with Breaking Bad. That's another story. Yeah. And yeah, and also it's also kind of weird, right? I'm also talking like those streamer, like VTuber, but really, since there's not so much we want to talk, just talk, man. Let's talk. Let's chat. And hopefully I still notice you guys there. And to the Sonic the Hedgehog, very sorry I didn't reply to you in time. Yeah, very, very sorry. Oh, there's also slightly drop frames, really. 117, 0.1%. At least this is what I read on OBS. Maybe I can close the music. I'll just open desktop audio, because we are almost approaching that period. Yeah. And also after this stream, I will immediately just go and sleep. Okay, I'm not going to pretend that I'm not tired. I'm actually tired. I mean, what also going to make me tired is when I'm waiting. Yeah, it's also when I'm waiting for the launch cadence. Let's say the launch is supposedly to be that day, but it got scrapped, and then it just turns to another days, or maybe they decided to just go another week. That's going to tire me, because imagine I've already prepared for the day. Okay, I just prepare for that day, and I just like, oh no, no way. But better scrap than rot, right? And for you guys still new with the how do I say, with the term, RUD or RUD stands for rapid unscheduled disassembly. Yeah. So, or just another words to say the rocket fell. Another words also to say oopsie, the rocket literally breaks down and what so on. That's basically RUD in the nutshell, what it actually means. Let's see. And yeah, and also before they finally just go and stream says anything, let's talk a little bit about hobbies there, because I just forgot to actually speak about this properly. Yeah, my hobbies, if you even ask me. Actually, I like reading something. I actually like to read a lot. I mean, it can be anything. I can go there and just read something from article, or maybe I can go and study a little bit. So, for example, if I decided I want to learn about rocketry, right? Because I do want to understand a lot about calculation about some things. So that's what reading can be used. But sometimes I want to read for leisure, you know. Let's say, for example, if I want to read manga or manhwa, whatever comic, that's where I'm going to read something because it's interesting. There's nothing else you need to do. And also, I like to watch videos, you know. Watch videos, any random videos. As long as it's still interesting, I'll just watch it. That's all. And for video games, well, I do like it, but let's just say not in the category super deep into it. Maybe you can just call me casual, but mostly I can say I'm in the category. How do I say? If I can describe myself, it's not like super casual. Yeah, because really I don't like playing Candy Crush. It's like I want to play some things, even some things like, let's say, for example, maybe Super Mario Brothers, other games, and also whatnot. But I just like my nerve is not yet my how do I say, my instinct is not 100% there yet to even play this game. So I just like, there you go, another day, another me. Yeah, hard to press myself to really do it, play some things, but it is what it is. And yeah, looks like we might actually get this one. Fury burn will coming up soon, so I'll just go into the desktop right. Alright, and also for you guys still watching here, welcome. Although from my stats, not many people just watch here. I mean, there's ones, but for whatever reason just tune out. But whatever, if you are still watching, thank you. I'm very happy. I'm very happy, even if it's just one people watching here right now. I'm very grateful. Okay, I mean, I don't expect to make any real living here for maybe the longest time, or maybe forever. I don't expect it. Let's just say this is now considered as my for just basically my stint, nothing else. And yeah, let's see. We should have another Curie burn coming up soon. And this Curie burn will be used to circularize the orbit. You know, let's say, for example, if it's elliptical, maybe let's say 180 kilometers by, let's say, 550. What this Curie burn will do is that at the apogee, or basically at the peak of that altitude, 500 plus kilometers, it will ignite the Curie to actually circularize the orbit, of course. And also, once it's fully circularized the orbit, all that's left is going to deploy 8 of those CubeSats. So we are going to see soon. It's not going to be that long. And yeah, for you guys, viewers coming here, welcome. We just actually witnessed the launch of the Electron rocket from the launch complex 1B. Yeah, you can say the newest head after the original LC1, or you can say retrospectively can be called as LC1A. So okay, should be to reburn anytime from now. Okay, so let's go. Okay. Oh, QE burn should start anytime soon. Or maybe it's already currently in the process of burning right now to circularize it properly to the orbit 550 by 550 kilometers. Okay, it should have already begun. And looks like tracking might be good so far. As you can see, there is two antennas there. One is from the Canary Islands, or if I remember correctly, specifically in the Azores region, basically an autonomous region of Spain. And also another one will be actually in the, if I remember correctly, if either is either not from Lisbon, it's either in the Spain, Lisbon, Portugal. It actually might be the Spain, because too much technicality there.
Welcome back. You
If
are
you
joining
know-
us just in time for payload
If you know
deployment of 8 satellites for
how
OroraTech's
Portugal and actually
wildfire
Spain
detection mission.
just basically
Now, if you missed liftoff earlier today, it was
basically
our 63rd
side by
launch
side
and a nominal one
neighboring
through
country
Max
together.
Q,
You know
main engine
how it
cutoff,
looks like.
stage separation, second stage startup, and second stage cruise to the mission's
Alright.
nominal transfer orbit, where it separated the kick stage in preparation for payload deployment.
Alright,
coming
so
up in
QE burn
just a
has
few
already
minutes.
completed,
Since the kick stage's
and
release
in a
from
few minutes
Electron,
we will see
it has since completed its
the
first pass of Earth
first
and
and
lit
second
its
payload
carry
will be
engine to
deployed,
position
and then after that,
itself in a circular orbit.
after quite some
We're
time,
now
will be
waiting for
3 and 4,
confirmation that the
and also
engine has
another
shut off,
sometimes will be
which
5
will
and
mean
6,
we're
and
just moments
finally
away from
another
payload deployment for
will finally
OroraTech.
sometimes will be
Let's listen in
7
now
and
for the
8.
calls from Mission Control for confirmation that engine cutoff has occurred.
Alright. Oh, looks like it's still ongoing.
QE cutoff confirmed.
Alright, QE cutoff finally confirmed here.
Nominal final orbit achieved.
Alright, already nominal final
Carry
orbit, which
shutdown is
means
confirmed.
it's already
Excellent news
reaching
for the mission.
550 by
Now less than a minute until the
550
8 OroraTech
kilometers
satellites
of
are
altitude.
released from the kick stage
So
to begin
the
their
launch
wildfire
inclination
detection mission.
right now,
The satellites
properly
will be
at the
released from their
right
dispensers two at a
azimuth
time
to
across
it's
4
97
orbits.
degrees,
First deployment is now
uh,
just moments away.
and also it's already in the correct orbit. All that's left is the payload deployment, and this one is the how do I say, the CGI simulation of how it actually deploys, right? So look at that. If I remember, this is a payload dispenser. Yeah, should be payload dispenser. We might see. Let's see. Any seconds from now.
Deployment of payloads Untitled SC and Esperanza confirmed.
Okay. Looks like the
That is 2 down, 6 to go for
Alright.
OroraTech.
the
Now,
first
each
and
deployment
second
takes
payload
place within
has
seconds
already
of each
been
other, so we won't have long to
has
wait
already
for the
been
next pair to be released.
successfully separated from the payload dispenser. And yes, CubeSat, it has its own payload dispenser to actually dispense the CubeSat to the intended orbit. And also maybe you can see why there is actually spaces between those payload deployment, right? Because one of the other reasons is that
Deployment of payloads Crimple Bro 2 and Thermoraptor confirmed.
alright, and also the payload 3 and 4 has already
That's
finally
4 down, halfway through the deployment sequence here.
already
4 more to go.
already
and then
finally
next minute
deployed.
or so.
And you might see why there is spaces in between two. That is actually to prevent the satellite collision in between of these. And also another purpose is that by spacing it out, it also can cover it. It also can be used to cover the constellation, of course. That's why it actually needed. And this is how you can see in very close shot of that CGI simulation there. And ready for the payload 5 and 6.
Payloads Crimple Bro 2 and Till Infinity confirmed.
Alright, already deployed. Payload 5 and 6.
6 satellites on
And-
orbit now for OroraTech. Only 2 more to go to complete the full payload deployment.
Alright, and good to go. And after that, the payload deployment will be fully completed. It will be payload 7 and 8. And after those that complete, Huey will be burning for a second burn, mostly to deorbit it from, mostly to deorbit, and also to re-enter back to Earth. Finally conclude those missions, and we'll see. Any seconds from now, and
Expected deployment of Neurospicy and Langer to space.
Now on their journey to finding hot wildfires near you.
Alright.
That's mission
So,
success for Electron. with
basically,
payload deployment
mission
confirmed.
success or
Congratulations to the team
confirm?
and welcome to orbit for OroraTech. Your mission is now underway. So that's 224 satellites delivered to space, 63 missions, 3 launches in 2 weeks, all achieved by one team. So well done to everyone involved at Rocket Lab with another mission success for Electron.
All right.
And we'll
So
be back
this
for
is
the
pretty
pack again
good.
soon with our next launch from Launch Complex 1.
As always, thank you for joining us and sticking with the mission right to the end. Stay locked to our social media feeds for up-to-date information on all things happening in the lab. Until
Yeah.
next time, this is Rocket Lab Mission Control, signing off.
Alright, so that's it. Thank you. Thanks to the team. And also that we are good. Okay, so this is how the launch pad looks like right now. Pretty good. Alright. And that's it, guys. Nothing else to watch anymore. And final message from them. Yeah, so thank you for watching. And yeah, it looks like I can also conclude this live stream because obviously there's nothing better to do right now. So thank you so much for watching, and also see you guys for the next launch, whatever next launch will be, right? And also I need to get myself some enough sleep. Okay, so that's it, guys. Take care and stay healthy. And also, this is Daniel Suguwa. This is Daniel Suguwa signing out, and goodbye. Bye bye. Take care. Alright, looks like we are complete. Okay, so we are going to end this stream soon enough. So ready? In 3, 2, 1. Okay, so that's it, guys. Happy good day ahead of you. Bye bye. Take care.